Hi guys, this is O-level chemistry, paper 1, specimen 2023, question 11. The equation for the reaction between ethyne C2H2 and oxygen is shown. When the equation is balanced, what is X? So the equation is that of a combustion of a hydrocarbon. So in order to balance this equation, we would use the general combustion equation of hydrocarbon, which is CXHY plus x plus y upon 4 O2, which will give us x moles of CO2 and y upon 2 moles of H2O. If you do not know this equation, remember it. It will help you in balancing combustion of hydrocarbon. Okay, now we have the value of x as 2 and the value of y as 2. And we have x plus y upon 4 here. So x is 2, y upon 4 would be 2 upon 4. 2 upon 4 is equal to 1 upon 2. So this is equal to 2.5 O2, giving us x moles of CO2. X moles of CO2 would make it 2 moles of CO2 and y upon 2. The value of y is 2, so 2 upon 2 is 1. So 1 mole of H2O. But as you can see, this is for the combustion of 1 mole of C2H2. The equation given in the question has 2 moles of C2H2 present in it. So what we would do, we would multiply this equation that we obtained by 2. When we multiply this by 2, we end up with 2 moles of C2H2 reacting with 2.5 times 2 is 5 moles of O2, giving us 2 into 2 is 4 moles of CO2 plus 1 into 2 is 2 moles of H2O. So this is our balanced equation for combustion of C2H2 as given in the question. And now what do they want? They want us to find out the value of X. And the value of X in the question is the moles of oxygen. So as far as moles of oxygen are concerned, what we have found out is that moles of oxygen are 5 in our balanced equation. So the correct option for this question would be option D. Question 12. 25 grams of hydrated copper 2 sulfate crystals are heated to produce anhydrous copper 2 sulfate and water as given in the equation. What is the mass of anhydrous copper 2 sulfate formed? And they have given us MR of anhydrous copper 2 sulfate and the MR of water. So the first thing we need to do is we need to calculate the MR of hydrated copper 2 sulfate, which is CuSO4.5H2O. So for this, the MR of CuSO4 given is 160, which we will add to the MR of water given, which is 18. And since there are 5 moles of water, we multiply it by 5. So 5 into 18 gives us 90. And we add 90 to 160 to end up with the MR of hydrated copper to sulfate as 250. Now, what we will do is we will perform a calculation. According to the given equation, 1 mole of CuSO4.5H2O produces 1 mole of CuSO4, which means 250 grams of hydrated copper sulfate produces 160 grams of anhydrous copper 2 sulfate. And the question asks us 25 grams of hydrated copper sulfate is heated. So 25 grams of hydrated copper 2 sulfate would produce how much of the anhydrous salt? So in order to perform this calculation, what we will do is we will divide 25 by 250 and multiply it by 160. The answer that we obtain would be 16. So the amount of anhydrous copper 2 sulfate produced when 25 grams of hydrated copper 2 sulfate crystals are heated would be 16 grams. So the correct option for this question is option B. Question 13. The relative formula masses of four compounds are given. A student has a 1 gram sample of each compound. Which sample contains the highest number of moles of oxygen? So, in order to do this question, what we will do is we will first calculate the number of moles of compound that is present in 1 gram of the sample. So in the case of option A, aluminum, this would be 1 upon 102, which would give us a value of 0.0098 moles of Al2O3. Now, the second step for this would be to find out the number of moles of oxygen atoms present in the compound. So in the formula, we have Al2O3, which means this would contain 3 moles of oxygen. So what we would do here, we would multiply 0.0098 into 3, which will give us a value of 0.0294 moles. And these are the number of moles of oxygen present in this compound. So likewise, we will have to calculate the same value for each compound, and then the value with the highest number or the highest value would be the correct answer. So moving on to option B, we have CuO, which would contain 1 mole of oxygen atoms. So what we would do is we would divide 1 by 80, which would give us moles of CuO as 0.0125. And since we have only 1 mole of oxygen in this case, so the moles of oxygen would remain 0.0125 moles. Moving on to option C, we now have H2SO4, which would contain 4 moles of oxygen atom. So again, the first thing we would do is we would divide 1 up by 98 as given, and this would give us a value of 0.0102 moles. 0.0102 moles. Now what we would do is we would multiply this value by 4 because H2SO4 contains 4 oxygen atoms. And when we multiply this by 4, we end up with a value of 0.0408 moles of oxygen being present. In the last option, we have HNO3. HNO3 contains 3 oxygen atoms. So the calculation performed would be 1 divided by 63, which would give us moles of HNO3 as 0.0159. Now what we would do is we would multiply this value by 3 because there are 3 moles of oxygen present, and when we multiply this value by 3 we end up with 0.0477 moles of oxygen. Now we have got all 4 values present. Now we would find out which value is the greatest. So out of these four, 0.0477 is the largest value that we have calculated, which makes option D as the correct option for this question. Question 14. 50 cm cube of 0.1 mole per dm cube silver nitrate is added to 150 cm cube of 0.05 mole per dm cube sodium iodide in a beaker. After the reaction, solid silver iodide is present in the beaker. What else is present? So, in order to find this out, first we will have to find out the moles of silver nitrate and the moles of sodium iodide that were reacted. So, the equation for this reaction would be AgNO3 plus NaI. This would give us silver iodide, AgI, and it would give us sodium nitrate, NaNO3. Now, what we have is silver nitrate and sodium iodide being present. So silver nitrate, we have 50 cm cube of 0.1 mole per dm cube. So in order to find out the number of moles of silver nitrate, 0.1 moles are present in 1 dm cube. 1 dm cube is equal to 1000 cm cube. So how many moles would be present in 50 cm cube? So what we would do is 50 divided by 1000 multiplied by 0.1. This will give us a value of 0.005 moles. Now, a similar calculation will be performed for sodium iodide. So for sodium iodide, we have 150 cm cube of 0.05 mole per dm cube. So 0.05 moles are present in 1 dm cube, which makes it a 1000 cm cube. And how many moles would be present in 150 cm cube? So for this, what we would do is 150 divided by 1000 multiplied by 0.05. This will give us a value of 0.0075 moles. So now we have obtained moles of both the reactants. In case of AgNO3, number of moles is 0.005, and in case of sodium iodide, the moles are 0.0075, which means this is a smaller value than the other one, making this the limiting reactant, which would mean that there would be an excess of NaI. It is in excess. So after the reaction is completed and all of the silver nitrate is used up, some of sodium iodide would be remaining in solution. So now let's look at the options to select the correct one. Option A, aqueous silver nitrate and aqueous sodium nitrate. Silver nitrate is a limiting reactant. It is used up. So silver nitrate is not present at the end. So option A is incorrect. Option B, aqueous sodium iodide, okay, which is in excess, yes. And aqueous sodium nitrate. Sodium nitrate is present, but in solution, right, are present in the beaker. Yeah, these are the correct ones. So option B is the correct option for this question. Option C has aqueous sodium iodide only. Sodium iodide is what remains. Sodium nitrate is also present in solution. So sodium nitrate is not mentioned, making option C incorrect. And option D, aqueous sodium nitrate only. In this case, they have forgotten to mention the presence of the excess sodium iodide. So option D is also incorrect. Again, making option B the correct option for this question. Question 15. When 0.1 moles of a hydrocarbon is completely combusted, it produces carbon dioxide and water. Now the hydrocarbon here is C5H12, pentane. When pentane burns in oxygen, 1 mole of pentane requires 8 moles of oxygen to completely combust and form 5 moles of carbon dioxide and 6 moles of water. Now, this is a direct comparison of the ratios of mole or molar ratios. So if they have said that the moles of C5H12 is 0.1, 0.1 is basically 1 divided by 10. So that would mean the moles of oxygen required would be 8 divided by 10, which would make it 0.8, producing moles of carbon dioxide as 5 divided by 10, which is equal to 0.5 moles, and moles of water as 6 divided by 10 equals 0.6 moles. So now we have obtained the moles of carbon dioxide, which they are asking us in the next part. What is the volume of carbon dioxide produced when measured at room temperature and pressure? So the number of moles of carbon dioxide obtained is 0.5. And we know that 1 mole of any gas occupies a volume of 24 dm cube. So if the volume of 1 mole is 24 dm cube, the volume of 0.5 moles would be calculated by multiplying 0.5 by 24 and dividing it by 1. So this would give us a value of 12 dm cube. So if 12 dm cube is our volume of carbon dioxide, this makes option D as the correct option for this question. Question 16. Carbon electrodes are used to electrolyze aqueous copper to sulfate. Which observations are made? So now the solution that we have is of CuSO4 aqueous. So at the anode, the anion would be oxidized, and at the cathode, the cation would be reduced. So comparing copper sulfate with water, because it is in the aqueous state, since we have the sulfate ions present at the anode, we would have oxygen gas being produced, whereas at the cathode we would have copper metal being deposited, because copper is less reactive than hydrogen. So copper would be the one that would undergo reduction at the cathode and not hydrogen. So the product at the anode is oxygen and the product at the cathode is copper. Now, based on this, what we would be doing is we would find out which option is correct. So at the anode, oxygen gas is produced. So option A says colorless gas forms. Yes. Option B says colorless gas forms. Yes. Option C says electrode increases in mass. No, nothing is deposited here in the form of a solid. And option D is also the same. So this is wrong. So automatically options C and D have been eliminated. And options A and B, one of these are the correct options. Now, electrolyte, blue color fades. Copper sulfate is blue in color, and when it undergoes electrolysis, the blue color disappears. So blue color fades. So as far as the electrolyte is concerned, still options A and B both are correct so far. Now let's look at the third part. At the cathode. At the cathode, what do we get? We get copper metal being deposited. So option A says pink solid forms. Copper metal appears pink in the solid form. So this is correct. Whereas option B says colorless gas forms. No, copper is not a gas. It is a solid metal. So all three correct are in option A, making option A the correct option for question 16. Question 17. Electrolysis is used to plate a metal coin with silver. The coin is used as an electrode in a suitable electrolyte. Which row is correct? Okay, so the first thing is, if the metal coin or the silver coin is being plated, it's not a silver, it's a metal coin that is being plated with silver. So a reduction has to take place on the surface of the coin in order for the silver metal to deposit. So this is happening at the cathode, first of all. So the options A, B, C, and D have anode and cathode in it. So we have concluded that the reaction would be taking place at the cathode because silver ions would be deposited. So Ag positive would accept electron and deposit as Ag metal from the aqueous solution. So the coin should be placed at the cathode. Options A and B are incorrect. Now, in order to choose the correct option between C and D, we need to find out which electrolyte will be used. The electrolyte used should be a soluble salt of silver. We know that silver chloride is not soluble, so it will not form an aqueous solution, whereas all nitrates are soluble. So silver nitrate in option D is a soluble salt, making option D the correct option for this question. Question 18. An endothermic reaction has an activation energy of X. Which reaction pathway diagram is the correct for this reaction? Okay, so first of all, this being an endothermic reaction will have its products placed above the reaction in the energy profile diagram. So in option A, the products are above the reactants, making option A thermic energy profile diagram. So option A could be a correct option. Option B is incorrect because the level of products is below the level of reactants, making this an energy profile diagram of an exothermic reaction, eliminating option B. Option C also has products placed below the reactants, making this an energy profile diagram for an exothermic reaction, eliminating option C. Option D has products placed above the reactants in the energy profile diagram, making this another possibly correct option for this question. Now, we have decided which of the four energy profile diagrams are exothermic and endothermic. So A and D are for endothermic. So the next thing we need to do is we need to find out the activation energy value being X. So activation energy is the energy between the reactants and the maximum state in the energy profile diagram, which is also known as the transition state. So in the diagram A, reactants till the maximum state is labeled as X, which is correct, making option A the correct option. Why is option D incorrect? Because in option D, X is placed between the products and the maximum value, whereas it had to go from the reactants till the maximum height, maximum level, so that it would be the activation energy. So making option D incorrect. So the correct option for this question is option A. Question 19. The formation of liquid water from hydrogen and oxygen may occur in three stages. Stage 1 has 2 moles of hydrogen gas reacting with oxygen gas, producing 4 moles of gaseous hydrogen atoms and 2 moles of gaseous oxygen atoms. Stage 2 has 4 moles of gaseous hydrogen atoms and 2 moles of gaseous oxygen atoms reacting to form 2 moles of steam. And stage 3 has 2 moles of steam converting into 2 moles of liquid water, which means steam is condensing in stage 3. Now the question is, which stages are endothermic? So in stage 1, we have a molecule of hydrogen and a molecule of oxygen converting into atoms of gases. So here the process taking place is bond breaking, and bond breaking requires energy, making this an endothermic process. So stage 1 is endothermic. Stage 2 has gaseous atoms joining together to form a molecule of a gas. So in this case, we have bond formation taking place. Bond formation or bond making is an exothermic process. So in this case, energy is being given off. So stage 2 is not endothermic. In stage 3, we have steam condensing to form liquid. Now, condensation is basically cooling. So, if something is being cooled, energy is being released or given off. So, making stage 3 also an exothermic process. So, stage 3 is also not the correct option. So, out of the three stages, the correct option that we have is only stage 1 as being the endothermic stage, making option B the correct option for this question. Question 20. In four separate experiments, 1, 2, 3, and 4, nitric acid is added to an excess of marble pieces and the volume of carbon dioxide gas formed is measured. In all four experiments, the same volume of nitric acid is used. The concentration or temperature of both concentration and temperature of the nitric acid are changed. The results of the experiments are shown on the graph. Okay, so this graph has volume of CO2 produced on the y-axis and the time on the x-axis. So as you can see, graph 1 and 2 are producing more carbon dioxide compared to graphs 3 and 4. So this shows that 1 and 2 have more volume of CO2 being produced, that means it has a higher concentration of nitric acid present. So we have decided that experiments 1 and 2 are using a higher concentration of nitric acid. Now we need to find out the temperature. We know that if the temperature increases, the rate of reaction increases. So according to this statement, experiments 1 and 3 have carbon dioxide being produced quicker than experiments 2 and 4. But the total quantity produced for experiment 1 is the same as the total quantity produced for experiment 2, but quicker. Whereas the total quantity of CO2 produced for experiment 3 is the same as the total quantity of CO2 produced for experiment 4, but quicker. This shows that experiments 1 and 3 are being performed at a higher temperature. So now the question states which statement is correct. Now we will consider each statement one by one. A lower concentration of acid is used in experiment 3 than in experiment 1. Lower concentration in 3 than in 1. This is correct because higher concentration are used in 1 and 2. That means lower concentration are used in 3 and 4. So concentration of acid in 1 is greater than the concentration of acid in 3. This option is correct. Option B, experiment 4 is faster than experiment 3. Experiment 3 has the CO2 being produced more quickly than experiment 4, which means experiment 4 is not faster than experiment 3. Experiment 3 is faster than experiment 4. This option is incorrect. Next, the acid used in experiment 2 is of a lower concentration than in experiment 1. In experiment 1 and 2, we have concluded that both of them are using acid of a higher concentration. So the concentration in experiment 1 is the same as the concentration in experiment 2, making this an incorrect option. D. The temperature of the acid is the same in experiments 1 and 2. We have concluded that experiments 1 and 3 have a higher temperature, making experiments 2 and 4 being performed at a lower temperature. So, the temperature of experiment 1 is greater than that of experiment 2 and not the same. So, making this option also incorrect. So, the correct option for this question is option A.